All right, hello class. Welcome to this video on the assessing regression models practice. So you didn't have to do all the practice problems. You only had to do the first problem, and you only had to do you didn't have to do part A. But in this video, I'm going to cover part number 1 and 2, showing the residual plots, and then the whole the entire practice set. All right, so let's go ahead and get started. So for number 1, we want to draw a residual plot, determine if the regression model is appropriate, and then compute the standard deviation residuals, interpret it, compute the R squared, interpret it. So there's a lot going on in this problem. So first off, let's do the residual plot. So if we want to do the residual plot, we're going to need to know what the equation of the least squares regression line is, which they provide here, right? So we're going to need to develop a column, some columns here. We're going to need y hat, and then we're going to need to calculate the residuals, right? And so if we need to calculate the residuals, well, I need to do y minus y hat. Okay, remember that's how you calculate the residuals. All right, so what we're going to need to do is basically plug in the x value for x, right? The x value into the least squares regression model. And if we did that, that would give us y hat, right? Because that's what we're looking for. We're looking for y hat. So if we plug in 0 into this, for example, we would get 4.64 plus 1.21 times 0, 1.21 times 0, 0, and then we get 4.64. All right, so then if we do that, that's going to be our y hat. Next, we're going to plug in 1. So we're going to replace this with 1. And so we get 4.64 plus 1.21, which is 5.85, and so on. And if we were to do the y minus y hats, then that means that we're going to take the first y value minus this y hat value. So we got to do 4 minus 4.64, which is negative 0.64. And the next one, we're going to do now the next y value is 8, so this changes to 8 minus 4.64, which in this case is 3.36. And that's how you get those other values. Oh, wait a second, sorry. I put 4.64 here. It should say, I should have written 5.85. So that's going to change our number there. So we got 5.85, oops, which is going to change this to 2.15. So this number should change. All right, so I went ahead and calculated the other values using the same process here. And so keep in mind that I'm going to be using all my calculations. I'm going to be doing all my calculations in 2 decimal places. Because in the homework set, they're gonna ask you to round it to 2 decimals, except for the R. I believe for the R they want you to do 3 decimal places. So I'm gonna try to follow what the online Canvas homework says to kind of give you more practice and give you an idea. So 2 decimal places unless it's like an R value or something. All right. So let's go ahead and finish off the rest of this problem. So we got the residuals. Remember that these are your residuals. And so basically you're done for the table as far as the residual plot is concerned. We're going to need to add more to this later, but for the residual plot, we only need to know the residuals on the y-axis and the x values on the x-axis. Okay, so let's go ahead and draw the residual plot. So let's do it over here. So remember, when you do the residual plot on the y-axis, you're going to have your residuals. And the x-axis is reserved for, well, the x values, right? Okay, so, and you usually have a 0 line when you do this, right? So when you do a residual plot, you have 0 in the middle, in the middle of the y-axis, and then you have your positive numbers above, negative numbers below. So if you look at your residuals, your highest number is about 2. Your lowest number in the negative is about -1. So we're going to go by ones. Yeah, we can go, let's go by, yeah, one seems fine. So actually we'll go by 0.5s. 0.5, 1.0, 1.5, and then 2.0, and then we'll go 2.5, okay? And those are positives, and then we have some negatives. So we'll do the same here, -0.5, -1.0, -1.5. Okay, so that's for my residuals. And we're doing that based off of these residuals right here, okay? All right, next we have x is 0 through 6. So let's go all the way from 0 to 6. Oh, and I didn't mean to label this. That's funny. I didn't mean to label the x line. I was meaning to label the x-axis here. There you go. All right, that's better. So we got our plot. Now we're going to go ahead and let's go ahead and plot the numbers. So for x equals 0, you get -0.64, which is, a little bit past the -0.5 mark here. When x is 1, you get 2.15 for the y minus y hat. Next number is -1.06. -1.27. 0.52. 0.31, and then 0.10. All right, so when you look at the residual plot, remember, you're looking to see if there's any patterns or lack of patterns in the data, okay? So we don't have to, I don't believe in the problem we have to interpret it. However, if we look at it, yeah, you just want us to draw the plot. Oh no, actually it says determine if the regression model is appropriate. So we do have to interpret it. Okay. So we have a residual plot. Remember, if there is a lack of pattern in the dots here for the residuals, that indicates that the model is appropriate. So if you look at this, about 3 of the dots are below the 0 line, and about 4 are above. So basically almost 50% of the dots are below the 0 and almost 50% is above the 0. That indicates that there's some kind of randomness to this pattern. There's clearly no pattern to this set of dots, right? It's random. So if I were to toss a coin, it's a 50-50 chance that the dot is going to go above or below, right? And that seems to be the case here. Roughly 50% is below and roughly 50% is above. And so therefore, this indicates that there is a lack of pattern, okay? So there is a lack of pattern and it seems random. And because of that, because it's random, that means that the residual model, the regression model is appropriate. Okay, so this is part A, and then part B, the regression model is appropriate. All right, so now part C. Compute the standard deviation of residuals. So in order to compute the standard deviation of residuals, we're going to need more information from this chart. We're going to need to know the residuals squared. Okay, so we're going to need to square these numbers. So I'm going to extend this column. All right, so we're gonna go ahead and square -0.64. We're gonna square this column right here. So we're gonna do -0.64 squared. So you got, and when you do this on the calculator, make sure you put it in parentheses. So it's going to be 0.41. We're going to round this to 2 decimals, remember. So this is about 0.41 and so on. So we're going to get the rest of those numbers. All right, so we went ahead and finished the rest of the numbers. Remember, we rounded to 2 decimals. So we squared 2.15 to get 4.62. We squared negative 1.06 to get 1.12. Every time you square a number, it's always going to be positive. So this column should always be a set of positive numbers. There should never be a negative number in this column. So just keep that in mind. All right, so we got our squared residuals. And remember, so we'll go ahead and do the calculation here. So remember, to do the standard deviation of residuals, the formula is you got to take the square root of the sum of the squared residuals. So sum of the squared residuals for y hat over n minus 2. Okay, so that means that you have to take the sum, you have to find the total of the last column. So you got to add up the numbers for this column. So if we add up those numbers, SSR for y hat, we'll get the total here, and we'll see what we get here. So we get 0.41 and so on. Okay, so it looks like we get 8.14. We get 8.14 is my sum of my squared residuals, and that number right there, that total, is going to go here in the numerator. And then we have n. N is how many numbers we have. So how many x values do you have here? You have 7 x values, right? So it's going to be over 7 minus 2. And so we got the square root of 8.14 over 5. And then we get that number. Remember to round to 2 decimal places. So we get 1.28. So that 5 there, we're going to bump it up. All right, so we have our standard deviation of residuals. That's a relatively small number, which means that looks like our regression model is making pretty good predictions, because on average, so we're going to need to interpret that anyway. So let's go ahead and interpret that for part D. It's saying that on average, my residuals are only about 1.28. So that's pretty good. So the actual y values are, on average, typically 1.28 away from the predicted value. Using the least squares regression line. Or yeah, in this case, this is using the least squares regression line that we have. Okay, so basically the actual y values have an error about 1.28 from the prediction. So from our prediction, it's 1.28 error from the y values on average, which means our errors are about 1.28, which is pretty small. That's pretty good. And so our thing is making pretty good predictions on average. All right, so part E, we want to compute the coefficient of determination. So that, remember, that's r squared. So we want to calculate r squared. So to calculate r squared, we're going to need more information. We're going to need to know the y bar, and we're going to need to know the sum of squares for the y bar. And the reason being is that the formula, let's go ahead and write down the formula for r squared. So to get r squared, we need to know the sum of the squared residuals for y bar, not y hat, for y bar, minus the sum of the squared residuals for y hat. We found that. We know what that number is. We found that earlier. Divided by the sum of the squares of residuals for y bar. Okay, so basically we need to figure out this SSR for y bar. Once we know that, we can figure out r squared. Right? So we're going to need to extend the table so that we can accommodate that. All right, so let's get rid of this data here. We're going to need to figure out y bar. So remember, y bar is the average or the mean of the y values. So we're going to average these y values. Okay, so that means we got to do 4 plus 8 plus 6 dot 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 all the way to 12. Divide that by however many numbers. We have 7 numbers, and so the y bar, we can get that number right now. Let's go ahead and add those values. So when you add them, you get 58, and then 58 divided by 7 is 8.29. So we're rounded to 8.29. Okay, so we got our y bar. What do we do with that? Well, we're going to need to extend this. We're going to need another column for y minus y bar. Instead of y hat, we need y minus y bar. Okay, so to figure out the first value, you're going to take the y minus the y bar. So you're going to do 4 minus 8.29. That'll give you your first value. It's going to be negative 4.29. And then we'll do one more. Instead of 4, now we're going to do 8 for the next one. So 8 minus 8.29 is negative 0.29. Right, and so on. All right, I went ahead and did the y minus y bar. Now the next thing we're going to do is we're going to square these numbers, y minus y bar squared. So we're going to do the first number, negative 4.29, square it. Then we do the next number, negative 0.29, and square it. And that's how we get those values. So let's go ahead and change this right here. It's about 18.40. And so on. All right, so we went ahead and fill in the rest of the values for the squared values for y minus y bar. So next we're going to determine the sum here. So we're going to do the sum of this column. The sum of the squares are the residuals for y bar. We're going to add up these numbers here. We do that. So if we do that, we get 49.40. Okay, so that's what you get when you add up those numbers. Notice that that's a large error in comparison to 8.14. So that's telling you that if you use the regression model, the sum of the squares for the errors is only about 8. But when you use the y bar, it's highly inaccurate and you get errors about 49.4. This indicates to me that because the error got high when we use y bar compared to using y hat, that means that this is a pretty good regression model. When we switch from the average to the regression model, the errors reduce drastically. Okay, so let's go ahead and calculate the r squared. So we have 49.40, 8.14. So we can go ahead and using the formula. We know that this is the SSR for y bar is 49.40. Same thing for the denominator. And we got for the SSR for y hat, it was 8.14. Okay, and then we're going to go ahead and calculate that. Remember, when you do this, put parentheses around your numerator when you're using the calculator. So we get 0.84 to 2 decimal places. Actually, because we're doing r squared, we're going to use 3 decimals here. So 835. Remember, when we're doing r squared, I think the problem wants you to do 3. So let's just keep it consistent. So 0.835. Okay, so what does that mean? That's pretty high. And what that means is that we reduced the error by 83.5% when we went from y bar to y hat. That's basically what we did. Another way of interpreting this, so we'll go ahead and interpret this in the usual way. is that 83.5% of the variation or variability in the y values is accounted for by the least squares regression line. And the rest of the variation, what happened to the other, 15% or so, 16.5%? Well, the 16.5% can only be accounted for by error, so by random chance. Okay, so by chance, those variations, or not really by necessarily by chance, but by other variables, basically other factors contributed to the variation in those y values. And so the least squares regression line is able to take into account most of the variation, 83%, whereas the other 16% or so is accounted for by other factors. Could be random chance, but it could be also other factors involved. So this is actually a pretty good model. 83.5% is pretty good, but just keep in mind that it's not perfect, right? All right, so that is it for number one. So let's go ahead and do number two. So we want to draw a residual plot and determine if it's appropriate. That's all we want to do. All right, so we're going to go ahead and calculate the y hat and the y minus y hat. That's all we need here for the residual plot. Right, so we're going to plug in 0 into our model. And in doing so, we get negative 3.25. Next, we plug in 1 into our model. And so we get 6.04 minus 3.25 and so on. I'll go ahead and fill in these values in a little bit. Now to do the residual, we're going to do 2 minus the negative 3.25. So 2 minus negative 3.25. Remember, a double negative turns into a positive, so this is really 2 plus 3.25, which is 5.25. All right, I'm going to go ahead and fill in the values for the y minus y hat, the residuals. And so now that we have our residuals, we can go ahead and draw our residual plots. Let's go ahead and actually do that down here. Right, so our largest residual is 5.25. Our smallest in the negative is negative 3.87. So that's our lowest one. So going from negative 4 to about 6. So let's go ahead and do that. And their 0 line is here. We'll make that the 0 line. 1, 2, 3, 4, 5, 6. We'll go by ones this time. And we got our x values here. And so our x values are, I think the x values are the same, 0 through 6. All right, so let's go ahead and verify that. Just make sure everything's good. Yeah, 0 through 6. And so let's go ahead and, so our first one is 5.25. Next one is 0.21, so it's pretty low. 0 or negative 3.83. Negative 3.87, so just a little tad lower, not really by much. Negative 2.91. Uh, 0.05. And about 5.01. So a little bit over 5. So about 5. All right. Now looking at this residual, so this is part A. Looking at this residual plot, there definitely looks to be a pattern in the residuals. There's a clear pattern of, and these two, for these two dots, remember, if the dots are, if the residuals are positive, that means that you are under predicting. So this is underestimation or under prediction. And then we have over estimation, and then we have underestimation, right? So there's a pattern of under, over, and underestimation here. And you could see that there seems to be a curved pattern in the residuals, right? If you were to kind of look at that. And that indicates that this model is inappropriate. Okay, so this is an inappropriate model for, this is for part B. Or just say not appropriate. So regression model is not appropriate. What this indicates is that, well, we weren't supposed to be using a linear model, because this is the equation of a line, a plus bx. It's kind of like mx plus b. So we used a regression line instead of a regression curve. We should have used something that was like a parabola, quadratic. So this indicates that we needed to use a quadratic model, something with x squared. How will such a model look like? Well, the model that we should have used, probably based off of this, should have been in the form a plus bx plus cx squared. So you see this part was for the line, but then because this is a parabola, we needed to be quadratic, so we needed to extend it and use cx squared. We needed to have something in the squared to be able to properly model this. But we haven't discussed how to find these equations, right? This is called quadratic regression. This is a very tedious calculation and something that you'll have to do in the calculator to be able to get an accurate model. All right, guys, but that is it for the assignment. Hope you learned something from this video. And as usual, I'll see you in the next one.